Ever wondered why blockchain is always about currencies? Well, here we at GCB Automation have come up with an innovative blockchain approach to upgrade its utility beyond just transactions. Our product WaterChain is a software-hardware based interface that utilizes blockchain and IoT to monitor and optimize wastewater. Water resource consumers during the time of registration for their resources are supposed to purchase IoT meter from providers that encapsulates all the necessary sensors within the device. Every device is associated with a unique device ID that is the basis of service registration. To ensure smooth and easy operation, we have integrated G-Sheet admin panel that would trigger a response to register a device in our backend database, which is MongoDB. Once the device is successfully registered, the consumers can then install these meters to their discharge ends with the help of a universal pipe fitting design that's compatible with wide size ranges. The pipe, once installed and activated, pings the global server with the inbuilt credentials and confirms its identity for real-time data exchange. The current prototype model supports macroscopic vision-based and microscopic sensor-based analysis. The vision-based analysis includes pressure line monitoring, flow rate summary, solid waste discharge, and histogram-based water type classification. Based on the background calibration and static camera position, the pixel fluctuations are computed in real time to obtain the flow rate in square pixels per frame. Similarly, solid waste detection uses the adaptive thresholding method along with edge detection to determine floating contours in a frame view. Finally, based on pre-trained water data and bit plane histogram segmentation, water type is detected. The microscopic analysis takes advantage of spectral and conductive properties of water. A microcontroller is interfaced with the IoT box, which gives the feedback voltage based on the resistance offered by the flowing water. Similarly, a photoresistor circuit is used to obtain the spectral feedback, which is a function of microsuspensions or dissolved solutes present in the water. Finally, these raw collected voltages are converted into meaningful info and then displayed at the user end. Coming back to UI design, the front-end UI is built using React.js framework. Users can first activate their device with registration panel and then log in to view their dashboard. The current version of the dashboard shows hour-wise qualitative and quantitative data. Moreover, it also shows previous trend and comparison along with credit consumption and performance. Users can switch to purchase screen in case they want to buy more water allowance and credits from bad performing consumers in their proximity. The transaction takes place through Waterdrop, which is a sort of specific blockchain currency. Moreover, if the users suspect the sensor data is having glitches, all thanks to the LivePeer streaming API, they can always generate the streaming created by their own IoT meters. We have built a Python library of LivePeer API that takes API key as an argument, and based on its functions, it can perform all the API services as per the documentation. With the help of this library, smart video streaming session can be viewed by the users anytime to ensure transparent and reliable user experience. We hope you liked our project. Our current prototype is made on Raspberry Pi and Arduino, which could be replaced with application-specific integrated circuits for large-scale production. Thank you for viewing.